Hi guys, Chief Near Krishnan on behalf of New Age Maritime Academy. I am getting lot of this thing from the candidates that need to show how the unit cutout is happening in MEC engines. By now mostly everybody knows, just want to. And another thing is, in this video, apart from unit cutout, another thing what most of them were asking was how the fuel control is taking, how the RPM control is taking place in MEC engines, in electronic engines, in the sense how exactly what is happening when the bridge is increasing RPM, how the engine is actually responding to that RPM. So these two videos, these two things I intend to discuss in this video. First, regarding the unit cutout, guys, just maybe you are aware of already. Before you cut out the unit, just ensure that engine is at 25% load at least, not more, not much. And unit cutout, as you know, there are. It involves. Depending on the problem which you face, whether you want to cut out only the fuel or whether you want to, if you don't want to exhaust well to operate, depends on the issues what you face. Accordingly, you have to take a decision. So, suppose for example, and cutting off the cylinder for a prolonged running, better to ask suggestion from makers at how much load I can run the engine on prolonged basis. For immediate action, you can reduce the engine load to about 25% and see whether the other units exhaust temperatures are stable. So first thing is, okay, I will show you the instruction which most of us already know. You go to chief axis and then go to chief limiters, and then here you have suppose if you want to cut out for number 3, select the number 3 and then put this value to 0 and then give apply. Then number 3 unit fuel won't go inside. This is for cutting out the fuel to a unit. Suppose if you are having a problem of starting air valve leak, or if you are having a problem of under piston temperature increasing, or a very minor leak in the exhaust valve, or fuel valve leaking, dripping, or fuel pump, whatever related to fuel, then you can do the you can cut off fuel to the unit. When the vessel is in close quarters or somewhere where, or heavy weather where you cannot stop the engine, so that time you can do like this. But as I mentioned to you before, for a prolonged running, better to get advice from the makers for at how much load I can run the engine after giving them all the parameters. The next cutout is suppose if you feel that your exhaust valve has been damaged and you don't want to run the engine with a damaged exhaust valve where huge sound, some abnormal sound is coming, and you suspect that the exhaust valve is gone and you don't want it to operate at all. From the MOP, you can only close the exhaust valve. Okay, if you see, depending on the MOP version, in the same page also, here also you will have. But in this version, we have another tab for the exhaust valve cutout. Suppose for number 3 unit, you want to cut out the exhaust valve from operating. You can select number 3 and then give cutout. So what is happening here is, if you cut out the exhaust valve from the MOP, it will keep the exhaust valve in closed position. So watch out for your problems, guys, on what is the issue which you are facing. There are some certain issues where you need to keep the exhaust valve in open position. So for keeping the exhaust valve in open position, you have to follow the procedure of you have to do it manually at the engine. The same thing I have discussed in the MOP operation. I have put a video of MOP operation. I have covered this. But anyway, since many people are asking me the same thing, I feel it's better I put this as a separate video in the YouTube channel regarding the unit cutout and how the engine is responding, in the sense how exactly the fuel injection and how the fuel injection is happening. That comes next now. And okay, I hope you are clear. And another thing is lubricator also. Suppose if you are if one of the critical running component is damaged, and if you don't have the critical spare for it, one of the engine component is damaged, and you cannot you need to fire other cylinders. You have to run the engine, so you don't want anything to happen in that unit. You don't have a spare basically, suppose. Unusual situation of course, but somehow you want to run the engine. So that time what you have to do is you have to isolate cylinder lubricator also. There's no point in injecting the cylinder oil in the unit where nothing is happening. So that time cylinder oil, as you know, it's very simple. Go to the auxiliaries and then give 0 here. So that there won't be any injection for the particular unit. So this is related to unit cutout. So now in the next thing, some of them were asking me how the engine is responding, how the engine responds if the bridge telegraph, which is set at suppose half ahead, if they move to full ahead. Basically how the fuel is getting controlled in MEC engines. If you increase the RPM, how the engine is responding. If you decrease the RPM, how the engine is responding. So some of them were asking me, sir, many oral questions, many oral survey. During my orals, our surveyors are asking us how the fuel injection is basically taking place in ME engines. My humble suggestion for you guys, please take this as a knowledge for whatever I am telling for your own survival also, apart from the exams. I am going to illustrate that here, but this is just my humble suggestion, because with my experience I am telling, mostly we are getting Batisabs who are not experienced in ME engines. That time only we have to tell them, especially chief engineer level, second engineer level. The moment you tell them about the basics, then immediately they can understand, because they know the basics of electrical. And if you get a experienced Batisab, please learn from them for your own survival actually. I'm telling not only for your exams, okay? Okay, coming to your question of how, suppose if the bridge is giving off ahead and I need to move to from half ahead to full ahead, suppose. So now what is happening in ME engine, as you know very well, ECU acts as an interface between the bridge and engine room telegraphs. So the ECU detects the set point variation and gives signal to ECU. In the sense, suppose if the bridge telegraph, if the engine is in bridge control, if the bridge has increased from half ahead to full ahead, the ECU gives the signal to ECU, engine control unit. As you know very well, ECU is engine interface control unit. It acts as an interface between the bridge and the engine room telegraph. So what happens now? The ECU, after receiving the signal from ECU, that set point has been changed from half ahead to full ahead. That time what it does is, it receives the signal and then gives signal to the CCU. So my the candidates' questions were like, how exactly the process is happening. I will explain so that accordingly you can have that knowledge. Everything, the signal transmission is happening between MPC to MPC. MPC, as you know very well, it is a input-output board. It is not a HMI. you can do the touch screen. It's not a touch screen panel, it is just an input output board, but a very costly board. It is having the ability to receive and to give output in the form of analog signals and digital signals. This is what is happening inside an MPC. It's having during my online session with you. In fact, all these things I wanted to share with you during my online course in during my specialized course session in ME engines. But since many people are asking me, I felt it's better I can put it in my channel. So coming to the point, the signal transmission is happening between the MPCs, okay, from EICU to ECU. As I told you, the transmission will be in the form of either analog or digital signal, which you can see in the MOP. You have channels, so that part I will come later. But what is the actual thing which is happening at the FIVA valve? That is what you are most of the candidates were more interested. So I will tell you what is happening there. Now assuming that ECU has received the signal from EICU telling that set point has been increased from half ahead to full ahead. Okay, so from half ahead to full ahead, now from ECU the signal goes to CCU, cylinder control unit, through the MPC, of course, that the set point has been increased, so you do accordingly whatever is there. So now what CCU does, that is what I want to explain in this video in a precise way. If you see what is happening in CCU, if you go to, okay, suppose for number 1 unit I am telling. So this is CCU1, okay. It gives signal, you see the J70, these are all input coming to the CCU MPC, okay. This is the output, okay. Input matlab in the sense feedback. Input in the sense feedback. This is the output J70. I am just showing this as an example, okay. The J70 junction channel, basically it gives its output to the FIVA valve actuator, okay. FIVA valve, as you know very well, it is having a proportional, okay. This actually, there is a junction box here, okay. They have not shown the junction box in the MOP. This is a cable, okay. This is just a cable which is coming from J70 port of MPC of CCU1 and going to the FIVA valve actuator. From the junction box, you can assume this is actually the FIVA valve proportional, okay. This is the FIVA valve proportional. Proportional contains this. This is a proportional valve having a solenoid, and this is the chamber where the card is there. The whole unit is considered as a 4/3 proportional. And what is happening is, from the MPC, the signal is coming through this cable, okay. Through this cable, signaling to the whole thing. We can call it as FIVA valve actuator also, but basically it's a proportional valve. This is a proportional valve basically. So this is attached to the FIVA, okay, to the body of the FIVA. This is the proportional valve which is connected to the body of the FIVA. This is the solenoid valve of the proportional. So what is happening is, from the MPC the signal is coming here. These are all multi-core cable, guys. So multi-core cable, it has multiple functions basically. It gives the input also and receives the feedback also. And so through this the signal is coming here from the J70 port, and from here what is happening, this energizes the solenoid. This is also a milliamp signal, okay, coming from the MPC. I will show you in that input output channel how the signal transmission is happening. This is a milliamp signal. Once if the RPM is increased, accordingly there will be a change in the milliamps signal, which is coming to the FIVA valve proportional, which energizes this solenoid, okay. This is the solenoid attached to the proportional. This is a proportional valve. Basically inside the spool is there. So what is happening, as you know very well, I cannot have the FIVA valve here, so I have shown in this, okay. So here basically what is happening is, you can see the proportional once it gives order from the solenoid to change the spool accordingly. Inside you have the spool inside also. This is basically a directional valve, which is actually then it controls. This is the proportional. This is what is happening here. This you can imagine like this. Okay, so this is actuating the solenoid FIVA valve spool. Okay, which of course in the detailed video of the FIVA valve you can find out what is happening here, how it operates the booster. Okay, that is you have to read it as a separate section. But since you asked, many people were asking like how it is happening here. This is how the signal is coming. This is the cable coming from the MPC and then going here through this cable, energizing the solenoid. This also signal is in the form of analog output anywhere between 4 to milliamps depending on the signal coming from the CCU. Okay, basically from the ECU. So now once the solenoid get energized, accordingly it will change the proportional valve spool, which in turn operates the FIVA valve. Okay, now please remember, from the same cable the feedback is also going. Okay, now I will show you in the MOP how the feedback is also happening. There are lot of feedbacks which is being received. This is actually the FIVA valve feedback which I showed you. This is going from the same cable to J30 channel. Okay, this acts as a input to the MPC. Okay, this is the output of the MPC and this becomes the input of the MPC. If you want to know what is the kind of input and output I am getting, you can refer to this input-output test view in the screen. This actually is in the maintenance input-output. Suppose you are selected for CCU1, so you can select the CCU1. Okay, so in the CCU1, suppose if you want to see what is the kind of signal I am giving to the FIVA valve, this is a J70, right? So the J70, this is the J70, which acts as the output. So if you see in this channel J70, you see here, this is the output, analog output. You can see in milliamps. If you click this, you can see 0 to 20 milliamps is the analog output from this port. So this is basically the kind of signal transmission that is happening, which actuates the proportional through the which actuates the FIVA valve here through the proportional by means of by energizing the solenoid, which in turn changes the activates the proportional valve, which in turn actuates the FIVA valve. Okay, so now regarding the feedback line, as I showed you, the feedback of the FIVA valve, which is coming from the same cable, it is going to the, you see here, this is the FIVA valve stroke, which is going to the J30 channel of MPC. So same like that, you have the sensor for fuel booster, you have the feedback sensor from exhaust valve travel. So all these things are giving analog, the sensor will give analog output in the form of milliamps. You can see here, this is for example channel 34. If you can see here in this channel 34, the same thing is happening, milliamps. This is the analog output from the sensor. This is the sensor at the exhaust valve. So like this, it's the things are getting, that's how the system is operating basically. So now overall I am telling, the RPM change, correspondingly there is a change in the milliamps signal, okay, from the CCU to the FIVA valve proportional. Okay, this is what is happening, and the same proportional is giving the feedback also. What you have to remember is MPC, from the MPC it is coming to the MOP by means of analog to digital converter. If the MPC, it is having the built-in inside, you have the as I told you, MPC has the capability to receive and to give analog and digital signals. Okay, so to the MOP it is giving the digital signal. That's why these are all digital. Whatever we are seeing here, this is a digital signal which is being read by our thing. So now another thing is just for since you asked about since many people were asking about the RPM increase, please remember guys, in ME engine ECU acts as a governor. So suppose if you want to increase from full ahead to C speed, the load up program or if you want to reduce also the load down program, all these things they are installed in the ECS. Basically it is the engine control system in the MOP software. If you log in with the maker's password, you will get to know the parent settings of the MOP and also the parent engine parameters, which is all parameter settings will be there. For example, blower cut-in, cut-off. So what I am trying to tell, ECU acts as the governor. So the load up program is integrated with the ECU also. Although ECU also knows what is happening because it is getting the output from feedback basically from the ECU. Basically in ME engine everything knows what is happening or what is being done by everybody. So that in the sense everybody means ECU knows what CCU is also doing. Everything is internet work. And of course once the RPM is achieved, you have the flywheel, we have the tacho sensor pickup which is giving its feedback to the tacho signal amplifier, then to the ECU. Now I have achieved whatever is the set point, the engine has now achieved. Using the feedback of then accordingly the signal will vary. So this is what is happening. So I hope your inquisitiveness is satisfied. So it's really happy to hear these kind of questions also from candidates. But what as I suggested to you before, these things I am telling actually we need to know for our own survival basically. So anyway guys, I hope this video you enjoyed a lot. So thank you very much guys. See you in the next video.